Let's see if it works now. I don't have a warning this time. Okay, so see, this function is always increasing. But if you find f prime of x, can anyone give us f prime of x for this function?
3x squared.
Very good. And if I set this equal to 0, what is x? You can say you get two solutions, and they both are, because it's quadratic, I get two solutions, but they are both equal to
0.
Very good. But can anyone give us the sign of this derivative?
Positive.
Always positive. As you see, the derivative is always positive. The function is always increasing. It's never negative. If the derivative is never negative, it can never have a relative max or min. If it's positive to negative, it will have a relative max. If it's negative to positive, it will have a relative min. But this derivative never changes sign, even if it's 0 somewhere. It's positive, 0, positive, no relative max. Positive, undefined, positive, no relative max. Negative, 0, negative, no relative minimum. Negative, undefined, negative, no relative minimum. It must change sign. Otherwise, the function is always increasing, and if this is negative, will always be decreasing. Okay, before we look at problems in the book, I need to say one more thing. Critical, they are called in this book values. I like to call them numbers, critical numbers. It doesn't matter. You can call them critical values or you can call them critical numbers. Okay, what are these critical numbers? Aha. Critical numbers are exactly those values of x that make the first derivative 0 or undefined. If a function does not have critical numbers, it cannot have max min. I'm going to put all this in writing and you're going to understand it in a minute. If it has critical numbers, there is no guarantee there is a max min. But if it doesn't have critical numbers, there is a guarantee that there is no max min. So I'm going to put this in writing carefully and slowly. Okay, critical number or critical value. So critical number is an x value where f prime of x is 0 or f prime of x is undefined. That's my starting point. In order to find max min, I have to find the critical numbers, where they occur. So a critical number is an x value where f prime is 0, or it can be both, not the same number, but a function can have x coming from here, a critical number coming from this possibility, and other critical number coming from this possibility, or none of the above. One, both, or none. So we have to investigate both of them at all times. And now here's the note. If a function, if a f of x does not have critical numbers, comma, it cannot have max min. Done. If there is no value of x for which its derivative is 0 or undefined, it cannot have max min. And one more note, and then we'll look at problems and find critical numbers or critical values. Note, if a function f of x has critical numbers or numbers, doesn't matter, singular or plural, comma, we must check if these critical numbers, if they are max min. No guarantee. No guarantee. We have to check. We have to investigate. If it doesn't have critical numbers, guaranteed no max min. But if it has critical numbers, I don't know. I have to check whether they change into max min. Okay, so I'm going to open on page 276. I have to see how I get back to the book. Sorry, 1 second. Where is my book? Here's my book. Here is my book. And section chapter 3. Okay. Here it is. 276. Unless I'm logged out or something. 276. It doesn't like it. Please. 27. Please. Okay. 276. And let's take a look. Identify all critical values. Relative max, relative min, relative minimum points, and relative maximum points. So the plural of max is maxima, the plural of minimum is minima. So let's analyze any of these graphs. Let's choose a graph. Which graph would you like to analyze?
4.
4. Okay. So looking at 4, can anyone identify a relative max? By identifying, I would like us to identify where x is first. I'm not asking how much is the maximum. I'm asking where I will find a maximum. For x equals?
-2.
So for x equals -2, very good. We see a relative max. Looking at this, would you agree that x equals -2 must be the critical value? Or critical number? It must be. X equals -2 must be the critical number. Do you see that the derivative on the left-hand side, or the tangent here, is positive and the tangent here is negative? That makes this point a relative max. What is its y value? I would like to identify its y value. In other words, f of -2. How much is that?
2.
Excellent. Is there another relative max anywhere? And can anyone tell us what is f prime of -2 before we continue? What is f prime of -2 here?
Undefined.
Awesome, because it's a corner. Who said that?
Vivek.
Thank you. So undefined because it's a corner. Perfect. We analyzed everything for -2. Is there another relative max anywhere?
Would it be a 3?
Yes, awesome. Thank you very much. X equals 3, a relative max. Okay. What is f prime of 3?
Zero.
Yes. Is x equals 3 a critical number?
Yes.
Awesome. And can anyone give us f of 3, which is the actual relative max?
1.
Excellent. Is there a relative minimum? At x equals
1.
at x equals 1. Very good. A relative minimum. Awesome. What is f prime of 1?
It's 0.
Careful.
Undefined.
Yes, y is undefined.
It's a corner.
Corner. Very good. Is x equals 1 a critical number? If there is a relative max or a min there, it must be a critical number. And finally,
Yes, it is.
yes, very good. And finally, f of 1.
-1.
Neg-
-1.
Awesome. Indeed, f of 1 is -1. Good. Awesome. I would like us to choose a problem from here and create a graph. They're asking us to, they're giving us some information and they say, come up with a graph. And we have infinitely many answers, correct answers here.
Could we do number 13?
Yes, let's work on 13. Very good. Let me copy it and then I'll stop sharing. So we said 13, and this is on page 276. 13. G has a negative derivative, g of x less than 0 over negative infinity 5 union 5, 8. G of x is a positive derivative over 8 infinity. And a derivative equal to 0, so that was g prime. So g prime of x equals 0 when x equals 5. Awesome. I'm just going to read it again just to make sure I copied it correctly. G prime has a negative derivative over this and this. Yes. It has a positive derivative over this. And a derivative equal to 0 at 5. Awesome. Perfect. So please arrange the information in a table. Please use a table. We're going to use this a lot. Okay, so here's x. Here is g prime of x. And now I'm going to put the information I have here in my table. And you'll see in a minute why. So I see that at 5, when x is 5, g prime is 0. Perfect. So this is done. We are told that there is something about 8. Okay, very good. So it says that g prime is positive from 8 to infinity. From 8 to infinity, g prime is positive. Done. G prime is negative between negative infinity and 5 and 8. They're not telling us anything here. But we're asked to create, so this is done. They're asked to create an example. There are many correct answers. They want one example. An example of a function, graph it, graph an example of a function that fulfills the given conditions. So here is our analysis, as we've done it before, without using the table. So between negative infinity and 5, the derivative is negative. What does the function do when the derivative is negative?
Decrease.
Awesome. So thank you. So when the derivative is negative, the function is decreasing. I don't have a number here. It doesn't matter what we put in. Now, between 5 and 8, the derivative is negative. What does the function do?
Decreasing.
Awesome. I don't have a number here. We're going to decide together. But what does the function do when the derivative is positive?
Increasing.
Very good. Question, before you look here. 5 comma whatever number you want. Is 5, the derivative is 0, is 5 a critical number?
Yes.
Yes. Every time the derivative is 0 or undefined, this is a critical number. Critical number. Now the next question. 5 comma whatever you want. Will it be a max, a min, or none of the above?
Neither.
Exactly, because the derivative does not change sign. Brilliant. So let's come back. This is very important to understand. Negative, 0, negative. Negative, 0, negative. Negative 0 positive would have been a relative min. But it's negative 0 negative. That's why this is not a max or a min. We cannot make it a max or a min. Okay, now let's move on to the next one. If we're not told what to do with 8, we can put a 0 in here if that's what we want. We have two options. We can put a 0 or an undefined. It doesn't matter. You want to put 0? We'll put 0. You want undefined? I will put a bar. And it will be a corner.
Do 0.
A 0. Okay, we want to put 0. Good. If we can add anything we want. What we cannot change is what they gave us, but we can add anything we want. So then is 8, since we consider that this is 0, is 8 a critical number?
Yes.
Yes, it is a critical number. Next question. 8 comma whatever we want. Will it be a max, a min, or none of the above?
It will be minimum.
Yes, it will be a minimum because look at the symbols, the signs that I have here. Decreasing and then increasing. So this will be a minimum. This will be nothing. Nothing. Whatever number you want to use. Okay, now we're ready. We did all the analysis. We understood what's going on here. So now we can put, as I said, we can put some numbers in here. We can add anything we want, but we cannot change what we are given. So I don't know, I'm going to put here 5 and I'm going to put here 1. So I have 5 comma 5. And I have 8 comma 1 because look, this is the function. We are not plugging in numbers. I mean, we're not graphing points on the derivative. We are graphing the function. And 8 comma 1, 5, 6, 7, 8 comma 1. So the function is decreasing and continues to decrease. So I'm going to graph something like this. Decreasing, passing through 5 comma 5, getting to 8 comma 1, where it's 0. So I have to make it so it shows it's not a corner. And that's it. So here is our g of x. This is a point where the function was decreasing, but this is a point where we decided that the function has a horizontal tangent. In other words, the slope is 0. And then it's increasing, so this is a relative minimum. The relative minimum is 8 comma 1. This point, 8 comma 1, relative min. Perfect pick. Thank you. So now I would like, since I know we only have a few minutes left, I just would like to find critical numbers for any function you want to choose. We may or may not have enough time to analyze the critical numbers. Do they turn into max min or not? We don't know. So let's start with a simple function like, let's say 27. So we have t of x equals x to the third plus 4x minus 2. So the question is asking us, please do not graph anything in this section. So I will assign something you're not supposed to graph, even if they say graph. No, we're not ready to graph. Find critical values or critical numbers and any relative extreme. Okay, we'll see if we can. I know we have 3 minutes left. So first I have to find critical numbers or critical values. What do I have to find first? in order to find critical numbers, what do I have to find first?
The derivative.
Of course. Excellent. Can anyone give us a derivative for this function?
It's going to be 2x squared plus 4.
Very
3x
good.
squared plus 4.
Good. Okay, perfect. So now I have to look at two different things. T prime of x is 0, and t prime of x equals undefined. Since it's a polynomial function, can any critical numbers come from this condition?
No.
No. So this is never. Now from this one, let's check. 3x squared plus 4 equals 0. This is a positive number. This is another positive number. Can a positive number equal 0? No. So it happens, no. It happens that this function has none, has no critical numbers. If it has no critical numbers, you cannot have a max or a min. For sure. Good. Okay, so let's start. Do I have time? 29. We'll stop when you tell me. So we have x e to 4x. As you see in this book, a lot of these problems are quite sophisticated. Okay, the same question. I have to find f prime. But here I have to carefully look and see a product. I have to apply the product rule. Good. So the first function prime is 1. So I have e to 4x plus x times this function prime. We discussed this at the beginning. E to 4x times the inner function prime. Okay, I have the derivative. Of course, I will factor out e to 4x. And I get 4x plus 1. So I have to analyze two things here. Can this be undefined? No. This is always defined, and this is always defined. None. But can this be 0? And the answer is yes. This can never be 0. But when 4x plus 1 is 0, how much is x? We move 1 and divide by 4. So this is the only critical number that this function has. So f prime of x, negative infinity to infinity, negative 1/4, 0. All I have to do is study the sign here and here. This is always positive. There is nothing we can do to this. This will always be positive. So since 0 is here, can anyone give us the sign of this plugging in 0? And I'll put the sign here.
It's positive.
Very good. So let's plug in negative 10. What is the sign?
It's
here?
negative.
Good. This is typical for what situation? Negative for
The
the
minimum.
Yes. So the relative minimum will be f of negative 1/4. Not this or this, right? This is where it happens, but I have to plug in the function. Negative 1/4 e to negative 1.